Good morning, class. We are looking at Chapter 6, Trigonometric Functions, Graphs of the sine and cosine functions. So we are going to cover graphs of the sine and cosine, graphs of the tangent, cotangent, cosecant, and secant in the next section. And in the following, the PS stands for the phase shift. More graphs, phase shift, sinusoidal curve. So the objectives, we are going to look at y equals a sine omega x and a cosine omega x by transformation. And we are going to determine the amplitude and period of sinusoidal functions. And we also are going to graph sinusoidal functions using key points. And finally, finding an equation of a sinusoidal. First, reminding everybody of what we have seen before. This is a unit circle x squared plus y squared equals 1. This is in general x squared plus y squared equals r squared. And the definition is that a point x comma y is represented as cosine and sine. Okay, class, and therefore we have all of these formulas that you see. X squared plus y squared equals 1. P has coordinates x, y. Sine is y, cosine is x. So that's the main part which gives rise to the rest of it. Okay, and then they're all definitions. So this gives rise to this and the rest of it. And of course, if you choose the radius to be r in general, not 1, then for example, cosine, which is x, becomes x over r, and the rest of them follow. Then we developed some identities. We're going to call them fundamental identities. Starting with this, if we replace the x and y with cosine and sine, we get to Pythagorean identities. Now, these are periodic functions. The period of every function is 2 pi except tangent, and therefore cotangent, every trigonometric function. Even an odd function, all of them are odd functions except cosine, and therefore secant. Remember, by that we mean cosine of minus x is cosine of x. And these are Pythagorean identities. Sine squared plus cosine squared is 1. Tan squared plus 1 is secant squared. And 1 plus tan squared is cosecant squared. These are called quotient identities. Tangent is sine over cosine. Cotangent is the reverse of that. And reciprocal identities. Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent, just to refresh your memory. So how do we graph something like y equals cosine x, or in this case, sine x? So we want a complete cycle, and we are going to go with x, y, and x comma y. This is, of course, the function. So what do we pick? We can pick any value from 0 to 2 pi, any arc, any angle, but we're going to stick with easy ones, the ones that are common arcs and we know. For example, you know the sine of 0 is 0, so we have 0 here, 0, 0 here. Pi over 6, or 30 degrees. Sine is 1/2, so 0, 1/2, 0, pi over 6 gives you 1/2, so pi over 6 or comma 1/2. Pi over 4, square root of 2 over 2. Pi over 3, square root of 3 over 2, and so on and so forth. So we write those values, and when we write in front of it, all you have to do, plot those pairs. Now we are looking at a complete cycle between 0 and 2 pi, everybody. All of these are common arcs you're supposed to know. So if you plot, it looks something like this. 0, 0. Remember, we are going to go from 0 to 2 pi. We are going to go from 0 to 2 pi. So 0, 0 is here. And let's cut this in half. This is pi. Let's cut it in half. This is pi over 2, and this is 3 pi over 2. Okay. And now pi over 6, halfway between, 1/3 of the way between 0 and pi over 2, has the height of 1/2. Pi over 2 gives you 1/2. This is the maximum height. And by the way, this is the minimum height. Okay. So maximum value or for the range, the y coordinate is 1, the minimum value is negative. And so the rest of them, pi over 4 is this value. And by the way, for this one, perhaps you can go to a decimal notation to see the representation. But let's stick with the easy numbers, pi over 6 and 1/2, pi over 2 and 1, 5 pi over 6 and 1/2, so on and so forth. So we go from 0 to 2 pi. So that's how you graph. The second method is to cut this into 4 arcs. So this piece, this piece, this piece, and this piece. 0 to pi over 2, pi over 2 to pi, pi to 3 pi over 2, 3 pi over 2 to 2 pi. So graph sinusoidal functions using key points, 4 arcs. Here's one arc. Here's this second arc, okay. Here's the third arc. Let's see if I can have, okay, one more color. Here's the fourth part. So what I want you to pay attention to is that 2 pi gets cut into 4 equal parts. When you divide this by 4, you get pi over 2. That's why we get 0 to pi over 2. And then we add pi over 2 to that, becomes pi. So from pi over 2 to pi. Then we add pi over 2, and again pi to 3 pi over 2, and finally 3 pi over 2 to 2 pi. This is actually, ultimately, is the faster method. And you look at the endpoints. For 0, you get 0, 0. For pi over 2, you get 1. So all the end points of those arcs, you plot them. That's practically good enough. Okay, everybody? So what do we notice? Domain is all real numbers. Again, after write anything, if you look at the graph, by the way, I'm going to go back. This was a complete cycle, one cycle from 0 to 2 pi. It continues indefinitely on the left and right, continues indefinitely on the left and right. This is a complete cycle. Okay, and then because it continues indefinitely, there's no restriction on the domain. So domain is all real numbers. Range goes from -1 to 1. Okay. It has odd symmetry. We've already proved that sine of minus x is minus sine x. So for example, if you pick any point, and connect it to the origin and continue the same distance, it gives you another point on the sine function. It's periodic with the period of 2 pi. X-intercept, if you look at the x-intercepts, I hope you see that you get n pi. So let's nice to level, okay. N is any integer. And the maximum value, pi over 2 here, 3 pi over 2, that means those values can be evaluated 2n plus 1 times pi over 2 gives you either pi over 2 or 3 pi over 2. And that's the general idea. What about y equals cosine x? We're going to do the same thing. We're going to go with easy common arcs, and we're going to go from 0 to 2 pi. Okay, so let's start with 0. 0 cosine is 1, so we have the pair 0, 1. Pi over 3 is 1/2, so we have pi over 3, 1/2. Pi over 2, remember it was 0. So pi over 2, 0. 2 pi over 3 is negative 1/2. Remember, 2 pi over 3, the reference arc that I mentioned is the same as pi over 3. So the value is the same as pi over 3. You have to figure out the sign in the second quadrant. Cosine is negative. So 2 pi over 3, negative 1/2, and the rest of them follow. So we have those. We have those. And all you have to do, flood the pairs and go from 0 to 2 pi. This is a complete cycle. And I hope you notice again, we have 1, 2, 3, 4 pieces arc. So again, you divide the 2 pi by 4, and it goes from 0 to pi over 2, pi over 2 to pi, and the rest of it. So using 4 arcs, we get those. Now, in this case, this is 1 arc. This is the second one. This is the third arc, and here's the last. As you can see, if we go with this methodology, because we're going to discuss everything in a moment. If we discuss this methodology, we find the period of the function for a regular cosine is 2 pi, otherwise it may not be. And then we divide it by 4, and we have 1, 2, 3, 4 pieces. And the starting point 0 has the y coordinate 1. So this one 0 there. This one pi over 2, 0. This one pi minus 1, 3 pi over 2, 0, 2 pi 1. And again, you have to be extremely comfortable with common arcs, everybody. So with that being the case, we can generalize. And again, you really don't have to memorize that, but just remember this shape, and the next page that we are going to generalize, it will come to you. Again, going back, remember this is a complete cycle. It continues indefinitely on this side and on that side. Therefore, the domain is all real numbers. So the domain is all real numbers. The range is -1 to 1, just like the sine function. But it's an even function. You remember we said cosine of minus x is cosine of x. The period is 2 pi, just like sine. And then x-intercept happens at pi over 2, 3 pi over 2, and so forth. So again, in this case, this means at 2n plus 1 times pi over 2, that means odd multiples. Please understand the meaning of 2n plus 1, an odd number. The maximum and minimum occur at n pi. Okay, the maximum. So for y equals cosine x, the period is 2 pi, amplitude is 1. Now, whether it's, by the way, cosine or sine makes no difference. The period is 2 pi over omega. 2 pi over omega, the coefficient of x. If you have a number in front of x, that's how you calculate the new period. This one, remember, the coefficient of x is 1. And the amplitude is the absolute value of A. That's known as the amplitude. So now that we know that, let's do graphs, and we are going to look at them by various methodologies. Generally speaking, it is up to you to graph it, but it's good to be exposed to both methods. So we want to graph y equals 3 sine x by transformation, or this one in general. Well, we say we know that t is 2 pi and the amplitude is 1 if we have y equals sine x. What happens if we have y equals a sine omega x? Now the period is t equals 2 pi divided by w, omega actually, I should say it's omega, not omega. And the amplitude, which was 1 here, is the absolute value of what it means in essence. I want to make sure. If you go back here, the range is from -1 to 1. This one, the range is -a to a. Okay, so right here, because it's 3, absolute value of 3 is 3. So the range goes from -3 to 3. That's the concept that I want you to see. There is no number in front of x. We have the same period. But anyways, as far as transformation, first let's do the basic sign. We know the graph. And again, take a look at one complete cycle. Let me put the complete cycle there for you. This, by the way, whenever you want to graph a complete cycle and then continue indefinitely. This is what matters. So this is sine. And how do we go from sine to 3 times sine? By the transformation, we have to multiply it by 3. So there is a vertical stretch. So the same thing remains. This 1 becomes 3. So multiply by 3, vertical stretch by a factor of 3. So this guy goes up to power 2, 3. And again, this is 1 complete cycle. Okay, everybody, 1 complete cycle. This one, and then it continues both ways. Of course, this continues both ways. And believe it or not, that's it. So we have the same domain. We have the same period. What has changed? The amplitude was 1. Now the amplitude is 3. And therefore, the range is from -3 to 3 again. Okay? And therefore, the range. Okay. Y equals -sine 2x. Since we did this in the previous way, we're just going to write the general case. When y is sine x, we know the period is 2 pi, the amplitude is 1. When it's a sine omega x, the period is 2 pi over omega, and amplitude is the absolute value of a. That's as far as really the knowledge and information we need to know. And we start with y equals sine x. And then we do the transformation. We discuss this part at some point in the beginning or at the end, makes no difference. So when we compare, we notice a couple of things. This thing happens and this thing happens. There are 2 differences. This number, sine, you can think of it as -1 or just a sign. And this number is 2. So the meaning of this is flip over with respect to the x-axis. So we have the reflection with respect. So flip this over and notice just again a 1 complete cycle. Just if you look at 1 complete cycle, that's what happens to it. Okay, that's the meaning of this negative. And then we have a factor of 2. Factor of 2, when you replace the x with 2x, that means horizontal compressions the other way around by a factor of 1 over 2. And so what happens is that if you look here, we're going to go from 0 to pi. Now half of that, we go from 0 to power 2. This shrinks. Okay, this shrinks to power 2. And this is 2 pi, this shrinks to pi. So in essence, because the period originally is 2 pi, it is still 2 pi. Over here, the period has changed to simply pi. So to remind you, the period is 2 pi over 2. which makes it pi. The domain hasn't changed. And although it's -1 and it has flipped over, the range hasn't changed either. Okay, the range hasn't changed. It's because the absolute value of this number, -1, is still 1. So it remains the same as far as the range is concerned. But of course, it has flipped over. So again, basic transformation of sinusoidal functions. What about y equals 2 cosine 3x? And again, reminding everyone of the same thing here. When y was cosine, the period was 2 pi, amplitude was 1. If we have it as a cosine omega, the period is 2 pi over omega, the amplitude is the absolute value. Okay, so right away we recognize the absolute value of that is 2, and so the range has changed, and the period we divide 2 pi by 3. Just to give you an idea, we already have that. But here's the basic graph, and if we stick with, again, you can go with one or two. In this case, if we start with this one or that one, doesn't matter. If we start with this one, then we are going to multiply it by 2, a vertical stretch of factor of 2. So what I want you to notice, one complete cycle, and the only change is, now look at this point. Look at this point was 0, 1, and now it's 0, 2. And now 3. So it shrinks by a factor of 3 along the x-axis. In essence, this 2 pi gets divided by 3. So this will go this way, okay? It shrinks. This thing shrinks along the x-axis. So replace the x by 3x, horizontal compression by a factor of 1/3. So what happens here over here, we had 2 pi, now we have 2 pi over 3 as a result of this. And again, t is 2 pi over omega or 2 pi over 3. Domain is -infinity to infinity. Range has changed again because okay, the amplitude has changed and the range has changed. All right. So those are transformations. And as we looked at sine and cosine functions, we may have noticed they are so similar, the graphs, okay, such that sine is cosine of x minus pi over 2. The blue one is a sine function. The red one is a cosine function. But if you move the blue one to the right by pi over 2, becomes identical to the red one. Again, the blue one, class, the blue one, look at the graph. The blue one is really sine x, and it's the same as x minus pi over 2. So let me write that. Okay, the blue one, anyways. The blue one is sine x, as you can see. And the red one is cosine x, as you can see. Okay? Now, if you move one of them by pi over 2, you see the other one. That's the bottom. Okay. We can also see this is y equals sine x, and this is y equals cosine x minus pi over 2. So just move the red one. Move the red one by pi over 2 to the right. Now, if you use a graph and a graphing calculator, and if you graph y equals sine x and cosine of x minus pi over 2, doesn't give you two, it gives you just one graph. So how many graphs do you see? There's only one graph, and that's proving it graphically with a calculator. All right, we want to determine the amplitude and period of a sinusoidal function. And we said for y equals sine x, and the same thing for cosine x, the period is 2 pi, the amplitude is 1. But if it's a sine omega x, we divide 2 pi by omega to get the period, and the amplitude is the absolute value of a. And again, we have it here. And that works for both y equals a sine omega x as well as y equals cosine omega x. And by the way, in some texts, they may use b here, a sine bx. It doesn't matter, whatever the coefficient of x is. So for example, for this function, y equals minus 4 cosine of 3x, we want the amplitude is the absolute value of this number, makes it 4. We want the period 2 pi divided by 3. So 2 pi divided by omega. Omega happened to be 3. So divide by, and that's our period. For this function, amplitude is the absolute value of 3, which makes it the same number. The period is 2 pi divided by omega, which is 4. 2 pi divided by 4, which is pi over 2. Pi over 2. We looked at transformation. Now let's look at using key points. And many students find this a little bit easier and faster, but in any event, number one, come up with the amplitude and period of the function. Number two, the period has to be cut in 4 subintervals. 4 subintervals. And this is the period. And all you have to do, use the endpoints to obtain 5 key points, because there are 4 arcs and 5 key points. 4 arcs and 5 key. And all you have to do, plug those and come up with the sinusoidal function. Here's an example. We are going to use the key points. So first we need to do a couple of things. Number one, what is the amplitude? Absolute value of 404. What is the period? 2 pi divided by omega, which is 2. 2 pi divided by 2 makes it pi. And remember, the general graph looks like that, right? 1, 2, 3, 4. So let's cut this into 4 equal pieces, becomes pi over 4. So we're going to go from 0 to pi over 4. That's the first interval. Pi over 4 to the next one, we add pi over 4, makes it pi over 2. And then pi over 2 to the next one, add, we pi over 4 becomes 3 pi over 4, and finally 3 pi over 4 to pi. So please understand, this is very easy. So pi over 4. Now, put this number here, and then add pi over 4. Okay, so I want to make sure we understand. So put this number here, and then add, okay, put this number here, and then add, put this number here, and then add, okay? That's how you get all 4 subintervals. So let's go with 0, the very first point. So we have 0 as the first point. If you plug in 0, cosine becomes 1, so that's 4. 0 gives you 4. The next one is pi over 4. If you put pi over 4 times 2 is pi over 2. Cosine is 0, so the next one is 0. Now, so we did 0, we did pi over 4. Now we do pi over 2. If you put pi over 2 here, 2 times that is pi. Cosine of pi, negative 1 times 4. Again, just as an example, I want to make sure we understand that. If I put pi over 2, I get 4 cosine of 2 times pi over 2, which is 4 cosine of pi. Cosine of pi, we should know it's negative 1, so minus. That's how you evaluate it. And you can do the same thing with the next two numbers, 3 pi over 4 and pi. Again, if you put 3 pi over 4 here times 2 becomes 3 pi over 2 cosine is 0. If you put pi here, 2 pi cosine is positive 1 times 4. So plot 5 pairs. This is 1, this is 2, this is 3, this is 4, this is 5, put them together. That's all you have to do. This is a complete cycle, everybody. Now we are going to continue indefinitely on the left and on the right, and it will look like this. So we have a complete cycle. We add the same thing to the right and left indefinitely. That's unless they ask you for a complete cycle. And many times that's what you may have to answer. But as long as you can answer that, you can answer anything else. Okay. By the way, if it makes it easier for you, you can put this x and y and start writing 0 over 4 over 2, the rest of them, and then plug it into this and write either way. So those are the pairs that you have to value. All right. First, we are going to go with the, again, same methodology, okay? Number one, we notice that the amplitude is absolute value of this number, which is positive 3. And that means the range, when you have that for any sine or cosine function, the range goes from negative 3 to positive 3. That's the meaning. Now, what about the period 2 pi divided by omega? This is the omega of the pi over 4. Omega is the coefficient of x. When you divide 2 pi by pi over 4, you get 8. I hope everybody is okay with this. 2 pi divided by pi over 4. Pi and pi cancel each other. 4 times 2 is 8. So the period is 8. You're going to cut this into 4 equal pieces. You get 2. Which means we're going to go from 0 to 2, 2 to 4, 4 to 6, 6 to 8. Now again, whatever the beginning. For now, the beginning is 0. Later on in other sections, we see that it may not start with 0. And so we plug in. If I plug in 0 here, cosine of 0 is positive 1 times negative 3. So 0, if you plug in 0, gives you negative 3. Just as an example, if I do a few of them here, class, I'm going to say x, and I'm going to say y. 0 gives me negative. The next one is 2. If I put 2 here, 2 pi over 4 means pi over 2, cosine of pi over 2. So now let me actually just do that with details. So if I put 2 here, I get minus 3 cosine of pi over 4 times 2, which makes it pi over 2. Cosine of pi over 2 is 0 times negative 3, it is 0. So 2 gives me 0. Let me also show you 4. If I put 4, I get minus 3 cosine of. Now, 4 and 4 cancel each other, pi. As you know, cosine of pi is negative 1 times negative 3 makes it positive 3. Therefore, I'm going to write 4 gives me 3. So I hope you see it's very simple. Now I have only 6 and 8. If you plug in 6 divided by, it becomes 3 pi over 2. Cosine is 0, so 6 gives you 0. If you put 8, 8 divided by 4 is 2. 2 pi is, cosine is positive 1. This makes it negative 3. So we have those pairs. So we are going to put 5 pairs in a grid, okay? And in a grid, for example, if this is 3, this is negative 3, this is the first one, just for the sake of all. And let's say this is 8, this is 4, this is 2, this is the next point, 2, 0, and then this would be 4, 3, and then 6, 0, and then 8, negative 3. Again, this is not to scale, but that's 1, and that's a complete cycle. So you have a 1, and then you continue indefinitely 1 cycle, and then you have infinity. All right, when you graph this, and again, quickly, the amplitude becomes 5 because it's the absolute value of 5. The period becomes 2 pi over 3. We're going to cut this into 4 equal pieces. When you divide by 4, 2 pi over 3, divide by 4 becomes 2 pi over 12 or pi over 6. So each piece is pi over 6. So if the first one is 0 to pi over 6, the other one is pi over 6 to, you add pi over 6 to that, becomes pi over 3, and then pi over 3 to pi over 2, and pi over 2 to 2 pi over 3. I hope you see how you get that. Again, this is the first one. Now, to this one, add pi over 6, and it results in pi over 3. Now, if you add it, it results in pi over 2. If you add pi over 6, it results in 2 pi over 2. That's how you get those sub-intervals. So the first one, 0 to whatever this number, and then just keep on adding this to the endpoint. Add this one to the endpoint. So this endpoint becomes the starting point, and the new endpoint you add. Now let's plug in. Let's start with 0. Again, let's go here. If you plug in 0, sine of 0 is 0, and 5 times 0 is 0. So 0 gives you 0. Pi over 6. If I put, and let me show you a couple of them. I want to make sure that we understand. If I put pi over 6, I get 5 times sine 3, okay, times pi over 6. This is pi over 2, right? And what is sine of pi over 2? 1. So this is 5. This is how we evaluate. If I do the next one, pi over 3, that's actually easy. I don't have to plug. If I put pi over 3 times 3 becomes pi. Sine of pi, 0 times minus 0. If I put pi over 2, then let me show you. If I put pi over 2, I get 5 sine 3 times pi over 2. As you know, sine of 3 pi over 2 is negative. And so I get minus 5. And so we have those. Again, simple evaluation. Evaluate the function at the endpoint 0, pi over 6, all the way to 2 pi over 3. And that's what we get here, 0, 0, pi over 6, 5, pi over 3, 0. I showed you those, and you can figure out it. So just plug in. Remember, we're going to go from 0 to 2 pi. And now we're going to cut this 2 pi into 2 pi over 3. So this shrinks to 2 pi over 3. Okay, so this shrinks to 2 pi over 3. But the values now, of course, are 0, 0, pi over 6, 5. So this has been changed now. Remember, this is 2 pi over 3 because it doesn't show that. And so we have the endpoints that we calculated. And pi over 6, pi over 3, pi over 2, and 2 pi over 3. And now go indefinitely on the left and right. This is 1. Let me write that. 1 complete cycle. And this is the whole graph. And again, in many cases, they may ask you to come up with a complete cycle only. The key points actually is pretty simple. Let's continue with that. Y equals 2 sine minus pi over 2x. So first and foremost, the amplitude is the absolute value of 2, which remains as 2. What happens is, before anything, the amplitude really doesn't change. If you have a negative argument, whether it's sine or cosine or tangent and cotangent, doesn't make any difference, bring it out. Since sine is an odd function, becomes this. So the amplitude is still 2. But again, it's important to make sure this comes out, because otherwise it becomes difficult understanding how to graph it. Okay. The next step is to find the period of 2 pi over omega. So 2 pi divided by pi over 2 makes it 4. We want to cut this into 4 equal parts, becomes 1. So we're going to go from 0 to 1, 1 to 2, 2 to 3, 3 to 4. So this part is very straightforward since it's an easy number, right? Now we can put the 0 into the original function or this one, whatever is easier. It makes no difference. If I put the 0 into here, sine of 0 is 0, so that gives us 0. Therefore, 0 is 0. If I put 1, okay, I think it's easier to actually not put the positive numbers here, it doesn't matter. So if I put a 1 here, becomes pi over 2. What is sine of pi over 2? Positive 1. Times negative 2 makes it negative 2. So again, let me just, so if I put minus 2 sine of pi over 2 times 1, that gives me negative 2. So that becomes from very, that becomes very straightforward. Now let's plug in 2. If I plug in 2 here, 2 and 2 cancel each other. Sine of pi is 0, so I get 0 times any number. Number 3. If I put 3 here, 3 pi over 2. Sine of 3 pi over 2. Let's actually do number 3. If I put 3 here, this gives me negative 2 sine of 3 pi over 2. Now you know sine of 3 pi over 2 is negative 1 times negative 2 becomes positive 2. And that's what we have here. Okay, positive 2. If you plug in 4, makes it 2 pi sine of 2 pi. All right, so again, very easy. Just plot 5 points, class. On a grid, plot 5 points. 0, 0, 1, negative 2, 2, 0, 3, 2, 4, 0, and make up a sine function. You go indefinitely on the left and on the right, so you continue on both sides because they didn't ask for one complete cycle. They asked for the graph, and that's what we do. Let's do one more key point. And let's see what happens to that. There are different ways of approaching it. One way to approach that is for now to ignore that. If you recall, the effect of this is going up or down. Since it's negative, it goes down. So you can graph this and then take it down by 2. So for this one, the amplitude is absolute value of negative 4 or 4. The period is 2 pi divided by pi, which makes it 2. 2 pi over omega. 2 pi over pi, which makes it 2. Okay. We're going to cut this into 4 equal parts. So when we divide 2 by 4, we get 1/2. Now, this means we're going to go from 0 to 1/2, right, as far as the interval. 1/2 to 1, right, because we are adding 1/2. 1 to 3 halves, 3 halves to 2. So those are the 4 subintervals. Pay attention, this is 1/2, this is the first one. Remember, the last one must have this number in it. See, the first one is 0, the last one is 2, and then in between. Now let's plug in 0 into this function. Never mind this. If I plug in 0, cosine of 0 is 1 times -4. A 0 gives me negative. Plug in 1/2. Cosine of pi over 2 is 0 times any number is 0. Plug in 1. Cosine of pi is -1 times -4 makes it +4. So I hope you see that these are the pairs. So I did this one for you, this one, and this one. And figure out the rest. If you put 3/2, cosine of 3 pi over 2 is 0. If you put 2, cosine of 2 pi is +1 times -4 becomes -4. So now you have 5 pairs, 0, -4, 1/2, 0, 1, 4, 3/2 is 0, finally 2 minus 4, and we have all those 5 pairs here. Of course, this is not the graph. This is one complete cycle. So what do? You continue indefinitely on this side, on that side, and this is the graph for this, and we're going to move it down by 2 units. This takes place at the last minute class. So first this goes indefinitely on both sides. But the main part now, of course, is how do you work with this negative to take everything down by 2? For example, this becomes 1, 2. I hope you see that. This becomes 0, -6. This becomes 2, -6. You're going down by 2. 1/2, -2. 3/2, -2. So look at those, just those 5 points, and take them down by -2 and the rest of it. So take a look at those 5 points again. Okay, just as an example, look at this point versus this. So we shifted down by 2 points because of this. And this one, I'm just showing the, complete graph. This is one cycle. Okay, class, I'm going to move on. Hope everybody is fine with that. You're more than welcome to stop me if there is any question. Again, pay attention to what happens here. We graphed this guy, ended up here, a complete cycle using the key points. Going on both sides indefinitely, that's a complete graph. Then affecting the -2 is that to take this graph and take it down by however many units, in this case 2 units. For example, 1, 4 becomes 1, 2. Again, 0 minus 4 becomes 0 minus 6, so on and so forth. All right, can we find an equation for a graph? And here's the process. First of all, you should recognize if you're dealing with a sinusoidal function. Secondly, does it look like a sine function? Does it look like a cosine function? And by the way, you can make up both equations. In the sine function, you can have move to the right or left, the basic one by power 2 to becomes a sine becomes cosine, cosine becomes a sine. So that's not a big deal. But let's stick with one complete cycle here. If we go with that complete cycle, I hope you recognize it's a cosine function. And so let's plot and that's why we have this period is this, and we're going to figure out. So if this is cosine, we have to figure out the a and omega, and therefore we are going to put this point having coordinates 0, 3, this point having coordinates 1/2, -3, this point having coordinates 1 and 3. So what does it indicate? As you look at the given, right, the one that we just wrote, we are going to use a cosine function. Looks like a cosine. Look here. So we need the a. So as you can see, we go from -3 to 3. So the amplitude is 3. So we got that. We need to find omega. As you know, t is 2 pi over omega, and 2 pi over omega equals 1, right? That means omega is 2 pi over 1, or just do the cross product. I hope you have no problem with the cross product. If 2 pi over omega is 1, omega becomes 2 pi. So replace the a with 3, omega with 2 pi, and you're done. All right, we want to go with this function. You may notice this is a sine function that has been shifted for this part. So what I'm going to do, I'm going to stick with the one that is not shifted in essence. So this is the graph, and you know the sine function looking like this moment. This is the basic sine function. So you're looking at the sine function has been flipped over. So you put those pairs 0, 0, 2, 0, 4, 0, -2, 1, 3, 1. This is 3, 1. We're going to use the sine function. And you need to notice that this is a reflection over the x-axis of the sine function, so that the amplitude, whatever it is, it becomes negative. Remember, the amplitude is 2, the absolute value of that, right? The amplitude is 2. This has been flipped over. It makes a -2. So the amplitude is the distance 2, but the a is -2 because it has flipped over. Okay, next. Omega, the period is this number, 4. So 2 pi over omega is 4. So omega is 2 pi over 4 or pi over 2. You can interchange those two. You can put the omega here, 4 here. And so now we are going to replace the a with -2 and omega with pi over 2. And we are done. So what I want to quickly remind you is to recap this summary. If you want to graph a sinusoidal function using key points, 4 arcs, cut it into the basic function. You cut it into 4 equal sub-intervals, goes from 0 to power 2, power 2 to pi, pi to 3 power 2, 3 power to 2 pi, and find the endpoints for sine, or cosine, and those are the graphs for basic sine and cosine functions. And of course, you may have to change it when it gets a little bit more involved. Also, in general, when y is sine x, the period is 2 pi, the amplitude is 1. When it's, and again, the same thing goes for cosine. When y is a sine omega x, the period is 2t plus 2 pi over omega, and the amplitude is absolute value.